I'm asking you to imagine that this data came from a population of 5 college students. I know it looks like a sample of 5 college students, but I'm asking you to imagine that it's an entire population. Maybe it's 5 students who work at the same print shop. For some reason, it's a really small population of 5 college students. It's a complete group of people that have something in common with each other. I recorded 3 columns of data from this population. I recorded the number of classes that each person is taking, the number of siblings that each person has, and each person's age. Let's calculate the mean of each of these 3 columns. To calculate the mean number of classes, we just add up the 5 numbers and divide the total by 5. See what this comes out to. On the top, we have 3 plus 4, which is 7. 7 plus 5 is 12. 12 plus 4 is 16. 16 plus 4 is 20. We have 20 divided by 5, which is 4. The mean of this column of data is 4. Let's find the mean number of siblings. We have to add up the 5 numbers and divide the total by 5. We divide by 5 since we have 5 numbers. One plus 2 is 3. 3 plus 5 is 8. 8 plus 3 is 11. I actually wanted it to come out to 10. I'll change one of these numbers so that the total comes out to 10. I wanted to make sure that the mean comes out to a whole number for each of these columns. We can find the mean of the age column. The total is 125. 125 divided by 5 is 21, I think. No, it's 25. There's something else that's interesting about these columns of numbers that the mean doesn't show us. Notice that the numbers in the number of classes column are pretty close together. 3, 4, and 5 are pretty close together. The numbers in the number of siblings column are a little bit more spread out because we have 0s, 2s, 3s, and 5s. The numbers in the age column are even more spread out because we have 18, 25, and 32. So what's a way that we could actually measure the spread in these columns? What's something that we could calculate to actually show that this set of numbers has the least spread and this set of numbers has the most spread? Well, one option is to calculate something called the range. And I'll show you the idea behind the range. Let's put these numbers in order. You don't have to put them in order to calculate the range. I'm just trying to explain the idea of the range. Let's also put the number of siblings in order. Let's put the ages in order. You can see that in the set of numbers that has the lowest spread, the lowest and highest numbers are close together. They're only 2 apart. In the set of numbers that has more spread, the lowest and highest numbers are further apart because 3 and 5 are only 2 apart, but 0 and 5 are 5 apart. In the set of numbers that has the most spread, the lowest and highest numbers are even further apart because there's an even higher distance between 18 and 32. To calculate the range, we just subtract the highest number by the lowest number. 5 minus 3 is 2. 5 minus 0 is 5. And 32 minus 18 is 14. We can see that as the spread is increasing, the lowest and highest numbers are getting further apart, and the range is getting bigger. Let's write the range of each column of data. The problem is, will the range always go up when the spread increases? Well, actually, the range won't always go up when the spread increases, because the range only shows the amount of spread, or the distance between the lowest and highest numbers. Here's an example. What if we had these 3 sets of numbers? I'm not sure where these numbers would come from. Maybe we asked 5 people to tell us their ages, and then we asked 5 more people to tell us their ages, and then we asked 5 more people to tell us their ages. The important thing is that even though the range is staying the same, the spread is actually increasing from left to right. All 3 sets of numbers have a range of 10, because 20 minus 10 is 10. But when we go from left to right, the middle 3 numbers are getting more spread out. As the middle 3 numbers are getting more spread out, nothing is happening to the range. So the range actually doesn't tell us everything about the spread of the data. The range doesn't tell us anything about the overall spread of the data. It only shows how far apart the lowest and highest numbers are. So the range is limited as a way of measuring spread. Let's try to think of a better way to measure spread. The mean number of classes was 4. The mean number of siblings was 2. And the mean age was, oh, I'm sorry, the mean age was actually 25. That was my mistake. Hopefully you caught that before I did. The mean won't always be one of the numbers in the list, but in this case, it is one of the numbers in the list. We can see that when the spread increases, the numbers are getting further away from the mean, or the numbers are at least tending to get further away from the mean, because when we have low spread, these numbers here are all pretty close to the mean of 4. When we have more spread, the numbers are starting to drift further away from the mean, which is 2. And when we have the most spread, the numbers are starting to drift even further away from the mean, which is 25 in this list. Since sets of numbers that have more spread have numbers that tend to be further from the mean, maybe we could measure the spread by just measuring how far each number is from the mean. There's actually a way to do that, and the most simple way is with something called the mean absolute deviation. The range is the first way of measuring spread that we talked about. The second measure of spread that we'll talk about is called the mean absolute deviation. I just have to free up some space right here. Let's find the mean absolute deviation for the number of classes. We need one column for our data values. The data don't have to be in order. We can calculate the mean absolute deviation regardless of whether the data is in order.